Assalamu alaikum everyone. Today, inshallah, I'm going to review lecture 21, covering section 95, 96, 97. I will give a quick review. We already explained this in class. So, in the first part, about using what we call piecewise linear diet model. The word piecewise means as if we divide the characteristic curve to three pieces. So look here, this is the older characteristic curve. This is the relation between I and V in the forward bias region and in the reverse region and in the breakdown. Looks like one curve or one line. In the piecewise linear model, in the new, so this is the old system or the old model. In the new model, we are going to have straight line. So instead of having this exponential function, e to the power x, we are going to have the relation like a straight line. So straight line here, then a straight line here. Tamam? Straight line here, then a straight line. Everything will be like a straight line. How many pieces we have? We will have like, again, we are going to have straight line here, then a straight line. Straight line here, then a straight line. So we have one piece here as a linear relation, another piece number 2 as a horizontal line, like zero line, zero current, and the piece number 3, which is the breakdown ratio. So we have three pieces, so we call it piecewise. Piecewise means we divide the characteristic to be three pieces. So what is the meaning of this? Look at this very simple circuit. What is the voltage V we see here? The voltage V is I times R plus VA, right? Very easy. The voltage V is a series voltage across R and across V. If we need to sketch V versus I, so I'm going to take V on the x-axis, I on the y-axis. This will be a very simple relation. So the intercept or the intersection at the x-axis will be at V equal to VA. The intercept on the y-axis at I equal minus V over RA. The way we do it, just make I equal to 0. When I equal to 0, so when I equal to 0, in this relation, V will be equal to VA, which is this point. Then make V equal to 0. When we make V equal to 0 in this relation, I will be minus V over RA. So this is how we draw this very simple order 1 equation. So this equation is this line. Tamam? So this means we need a series resistor and the fixed voltage to construct this relation. What does this relate? How does this relate to our business in the diode? So the diode relation, this is the relation we had for the practical diode, the relation between IV with this polarity. Tamam? This is the polarity of I and V. Now we are going, instead of having this e to the power x relation, of course it's complicated than this relation, but I'm assuming e to the power x. We can have this as a straight line, and this guy as a straight line, and the guy in the middle as a straight line as well. So we'll have like three pieces. As you can see here, we have piece number 1, piece number 2, and the piece number 3. So we call it piecewise linear. We call it piecewise linear relation. So how can we know this means this straight line, as I just explained in the previous slide? The straight line means we have a resistor series with voltage source. So in our relation with the diode, when we have a straight line, we need to have a resistor and series voltage. This means I can easily find the equation of this line. I can find the equation of this line as 1.6 equal to I. I is this point. Look at this point, Shabab. I here 100 milliampere when V is 1.6. So it will be 1.6 equal to 100 milliampere times R. R is the slope. Slope of the line is 1 over R plus 0.6. 0.6 is a voltage here. It's clear that when I equal to 0, voltage equal to 0.6. And also this line verifies this equation. And this equation is the equation of the line. How can we find R? How can we find R? Can be found by knowing, by substituting this equation. Just solve this equation. Solve and in this relation, what we have here is simply this guy is like VD equal to I times R plus 0.6. Same relation we had before in the previous slide. What about the other relation? also the diode will be replaced here by a reverse battery. Look at the battery here, look at the diode here and its battery, and look at the diode here. يعني look at this, look at all of this. The diode here is replaced by a battery in the forward bias. Here the diode is replaced by a battery in the reverse direction. تمام. Also the same way to find the unknown R here, we need to solve this relation. This relation again based on this 2 point. Look at this 2 point. So this like I and this like V. So as you can see, V equal to IR plus 6. So we can solve this equation to find R. This is called piecewise linear. So it's another way to model the diode. So the diode will be like straight line, straight line, straight line. 1, 2, 3 pieces. So we call it piecewise linear. تمام يا شباب؟ Very simple relation. We can assume that يعني is a very simple piecewise. So we have either 1 or 2 relation. In the first relation, the diode will be replaced by a voltage source. In the second relation, diode will be replaced by open circuit. تمام. So this is simple piecewise model. Also in this chapter, so as you can see, we have practical model, piecewise linear, and ideal model. This is what we explained. In the practical model, you have this behavior. Look at this behavior. In the piecewise, you have this behavior. In the ideal, you have this behavior. And the diode will be replaced either by 0.6 volt here, 0.6 volt and resistor, or short circuit here. تمام. يعني the diode is always here. As you can see, the diode here is like short circuit. Diode here like short circuit, diode here like short circuit. تمام. So we have 3 models. Also, it covers half-wave rectifier. As you can see here, when the input is positive, so we have this polarity. Look at this polarity. The diode will behave like short circuit, assuming it's ideal. Assuming ideal, the diode will be short circuit. V out will equal to V input. So V out will be same as V input during the positive half cycle. What about when the input is negative? When the input here is negative, this means the polarity is like this. Look at the polarity, يا شباب. So the current will go in the reverse direction. Diode is open circuit. This guy is open circuit. Open circuit means V out is 0. No current in the circuit. Current is 0. So as you can see, we are only producing half the cycle. تمام. V out will be same as V input. يعني V out same as V input if the diode is ideal. If the diode is ideal, in this case, like here, like this line. If the diode is not ideal, V out will be less than V input by 0.6. Yeah, this difference will be 0.6 if the diode is not ideal. Not ideal means the diode is replaced by a battery of 0.6. If the diode is replaced by 0.6, this means V out will be less than Vs by 0.6. V out will be less than Vs by 0.6. تمام يا شباب؟ This is what we said. Now, if we add a capacitor, what does the capacitor do? Let's take it slowly. When the input start to increase, when the input starting to increase, so the input is starting to increase until it reaches to V max. Now the input equal to V max. This means all the power go in the capacitor. At some time, the capacitor will have the voltage here same as input V maximum. This is the time when the input reaches to maximum. Now the input start to decrease. Now the input start to go lower than V maximum. So the diode was on as long as the input less than the voltage across the capacitor. Once the voltage across the capacitor reaches to the same voltage as the input, the diode will turn off. And the situation now is that the output is now reaches to the maximum, and the voltage across the capacitor same as the input because the diode is on. Now the voltage will start to be less than V maximum. Is going in the lower side, which is this point, will go down. In this case, the input, the source, less than the voltage across the capacitor. So the diode now will be off. So the diode will be off once the charge of the capacitor reaches to the maximum of the input. And this is clear here, شباب. So as you can see, the capacitor is starting to charge in this part until it reaches to maximum, then start to decrease until it join again with the charging with the capacitor. So the diode is on while in the charging time. Here the diode is on. Look يا شباب, in this time diode is on. Then diode will be off. Diode will be off as long as the capacitor is charging. Diode is off means there is no diode. This guy is open circuit in this time, in all this time. تمام? In all this time diode is open circuit, and the power now is going, the energy going from the capacitor to the load. تمام? Then the diode will be on in the next cycle. So this is the on time. As you can see, the on time much less than the off time. تمام? This is how. So at the end of the day, what we have here is the diode is charging, discharging, and the off time much bigger than the on time. تمام? So this is the diode current. The diode current is on only during the on time. يعني look here, when the diode is on, you have some current ID. Then current diode is off, current ID is 0. Current ID is this red color. The current in the load in this resistor here equal to this guy. So the current in the load does exist as long as you have VL. VL is this guy, is the final current here. تمام? Maybe I change this color to make it easy. يعني what I'm saying, hopefully I can change this to make it green, for example, or make it blue. So the diode will be on as long as the diode is on. The diode will have current ID when the diode is on. The load current is the same as this red color, same as V load. يعني I can say that it's better to make it red color. So this is the load current, as you can see. The load current is following the same behavior as load voltage. تمام? It's clear now that this is the load current. Load current is following the same as load voltage. The voltage across the capacitor, across the load. So look here, V load يا شباب is this red color, and I load, the current in the load, is this red color as well. As long as you have IL, you have VL, you will have IL, but it's much lower than VL. يعني IL, what's IL here يا شباب? What's the value of the current here? Assuming you have some R here, some RL. You have RL here. So IL is simply VL over RL. Very simple. Which is this guy? Which is this current? تمام? Just making sure. Also review this equation. So the charge on the capacitor at any time, the charge on the capacitor equal to IL times T, the charge in the capacitor. تمام? This is from the relation that the charge on the capacitor equal to the current over the frequency. T here is like 1 over F. This relation same as when you say I is dq by dt. Remember this relation, this is the definition of the current, right? I is dq by dt. This means q is I times time. Q is I times time. This is the meaning of this relation. Also Q, the definition of Q is V times C, or CQ over V. This means from this relation we can see that C, yeah, this C here is ILT over VR. T is the same as 1 over V, or 1 over frequency. T is 1 over frequency of the input. Okay. Variable here, يعني remember variable here is the voltage here, the voltage at this place. The difference between the input. This is the output. Sorry, when the output is maximum and when the output is minimum. Variable is this voltage يا شباب. تمام. It's better to make it red color. So again, this is V load. This is V load يا شباب. تمام. So variable is this voltage. You see the voltage here. Variable is this voltage. So variable is calculated from this relation as IL over FC. The average voltage across the load. So this is the load voltage. Look يا شباب. The voltage across the load is this red color. So what is average point? Average point means as if you take line in the middle. You find the average of this variation. What is average? How much is this voltage? The line in the middle between the minimum and the maximum point. So it will be V maximum, the voltage here, minus variable over 2, because this voltage is variable. And I think it's clear that the voltage here, the average of the load voltage is V maximum minus variable over 2, which is this relation down. Look at this relation down here. V load is V maximum minus variable over 2. There is something called the peak inverse voltage. So the peak inverse voltage is the reverse voltage across the diode when the diode is reverse bias. So assuming this diode is reverse bias, يعني when the input is negative, this will be the polarity. تمام. The current will go this direction. So diode will be off, open circuit. What is the voltage across the diode when it is off? So peak inverse voltage is very easy. The meaning of peak inverse voltage is the voltage across the diode when it is open circuit. When the diode is open circuit. This means, so if we take loop here, now the current is 0 because the diode is open circuit. Current here is 0 ampere. تمام. Current is 0 ampere because the diode is open circuit. So the voltage across the diode equal to V maximum. So BIV here equal to V maximum. So very simple. BIV is the maximum voltage across the diode when it is reverse bias. It will be this point يا شباب. Look at this point. This point is the maximum voltage across the diode when the diode is reverse bias. Look at this point here. Look at the cursor. This point is the maximum voltage across the diode when it is reverse bias. What about if you have a capacitor? So the same circuit, but I have a capacitor. Here, the diode will be reverse bias during this region. When the input is negative, right? When the input is negative, the diode is reverse bias. Diode is off. So the maximum here, the maximum point, when the diode is off, is V maximum. So the input will be negative V maximum. At the same time, the voltage across the diode should be at the same time here, at this time. The input is negative V maximum with this polarity. The voltage across the diode is V maximum. The voltage across the diode is V maximum, this voltage. So if we need to find the peak inverse voltage, take KVL here. Take KVL in this loop. The peak inverse voltage when the diode is off will be 2V maximum. تمام. يعني if we need to find the BIV here, peak inverse voltage is the voltage across the diode when it is reverse bias, which is clearly twice V maximum. BEV here يا شباب is V maximum plus V maximum, twice V maximum. تمام. This is the voltage across the diode. Give me sorry يا شباب for this interruption. We will take another part of this video. I will stop recording here. Then there's another part of this review.